Hello everyone. Today I'm gonna go over the last section of the conic sections, section 8.4. I'm gonna talk about the hyperbolas. So first, let's give you the definition. Given 2 points, say F1 and F2, and a constant D, a positive constant D, and a constant, say K then, whatever, K positive. Okay? So a hyperbola is defined this way. A hyperbola is a set of all points P satisfying the distance from P to F1 minus the distance from P to F2, absolute value is equal to a constant K. Alright, that's the definition. Let me explain the definition to you guys. So pretty much what you have is this. You have 2 points. Say F1 is right here. Right now. F1 is right here. F2 is down here. Okay? And you have a constant K positive. You are looking for all the point P, such that the difference between the two distances equal to the constant. So you see why we have the absolute values, because since you do a subtraction, so we have 2 cases. Either PF2 minus PF1 if PF2 is longer, or if you have a point P right here, and you have PF1 minus PF2, whatever longer, you take that subtraction. Okay? And if all the point P satisfy the condition with the difference of the two distances equal to the constant K, you connect all the point P together, you're going to have 2 curves like this. Alright? And we're going to call it the hyperbola. And so, very similar to the way we define ellipse. For ellipse, we don't subtract. We add the 2 distances equal to a constant. Now, we do a subtraction. Okay? So, let me go over some basic properties of hyperbola, then we're going to talk about the equation. So pretty much you got hyperbola. Actually, you guys see hyperbola before, but we defined some function. Now it's ellipse. Okay. Hyperbola gonna have 2 foci like ellipse. There's F1 here, F2 there. But more than that, it's gonna have the asymptotes. The 2 line crossed like an X. This is the 2 asymptotes of hyperbola. And as you know before, hyperbola, the asymptote is a line where the hyperbola or the graph in general getting closer and closer, but never intersect at infinity. Okay, so let's go over some equation. And like before, I'm gonna modify the formula a little bit. It's a little bit different from the book. Instead of giving you like 2 different formulas, I'm gonna give you one that fits all the functions. So I'm sorry, all the equation. Number 2 equations. This is out of ink. Out of ink. As usual, I'll stick A with X. I'll let A go with X and B go with Y. Okay? So we don't have to change the formula. But now instead of adding, we have subtracting. So actually we still have 2 different formulas. But always say A go with X and B goes with Y all the time. Okay? So we have 2 types of hyperbola. The first one is this way. Okay? So let's call it the horizontal hyperbola, or left-right hyperbola. And the second type of hyperbola is this way. It's going to be up-down. Okay? So for the first type right here, the horizontal hyperbola is kind of go in the x direction. So x going to be positive and y is negative. So the equation for this one is going to be this. x squared over a squared minus y squared over b squared equal to 1. That goes this. And similarly, this type is vertical hyperbolas up and down. So it's gonna be on the y value. So we call it this way. Negative x squared over a squared plus y squared over b squared equal to 1. So on the y, then y is positive. It's go to the x direction, so x is positive. Okay? And people use it, in this case, x is real and y is imaginary. And similarly, in this vertical hyperbola case, x is imaginary and y is real. Okay? So let's go over one equation at a time. We're going to start with the first one. I'll show you how to sketch the graph. The first type, x squared over a squared minus y squared over b squared equal to 1. Here, x is positive, it means x real. We don't call major and minor axis anymore because real and imaginary. So x is real axis and y is imaginary. Okay, so let's draw the graph. Sketch a graph. So from the origin right here, you go left or right a unit. Okay, go up and down b unit. Alright, so what we're going to have is a rectangle. Alright, one more time from the origin for this equation. Alright, from the origin, as I say, I always use a for x and b for y. So we go left and right a units, and go up and down b units. And then I'll sketch a rectangle. Let's go through a, b, and negative a, negative b, parallel to the x-axis and the y-axis. Now, I'm going to draw the two diagonals of the rectangle. And guess what? The two red diagonals will serve as the two asymptotes for the hyperbola. Okay? Let's use green color. And since this is real for x, the two vertices, the two real vertices is going to be on a and negative a. And the graph will be like this. Okay? And the two foci will always stay on the real axis. So F1 will be right here, F2 will be right there. Okay? The two vertices. V1 is at negative a0, V2 is at a comma 0, F1 will be at negative c comma 0, and F2 will be at c comma 0. And how do we calculate c? This is negative c right here, by the way. This is c. How do we calculate c? Again, the diagonal theorem in here, and the longer side is going to be c. So c squared is equal to a squared plus b squared. You know a, you know b, just simply take a squared plus b squared, you got c squared. Okay? And one more thing, one additional thing into hyperbola that you haven't seen in ellipse yet. This is the two asymptotes. And of course the asymptotes in this case are lines, so we're going to have equation for line. To find the equation for line, we find a point and a slope. The point is right here at the origin, and to have to find the slope. Rise over runs, b over a. Slope is b over a. We have two lines, right? So slope is b over a, positive or negative, same value with just opposite direction. So the two equation is this: y is equal to b over ax, because it's going through origin. So no x1, y1 in here, and then plus or minus to indicate that this line right here is y equal to b over ax, and the other line right here is y equal to negative b over ax. Okay? And if you shift the entire graph to the new center, not at the origin, say you change the center from 0, 0, which is the origin right here, to a new center at h comma k, what you need to change, you change x to x minus h, you change y to y minus k, then your new equation will be this: x minus h squared over a squared minus y minus k squared over b squared equal to 1. Okay. And of course the asymptote going to change. That's what you see. A, B, C stay the same, so they won't change. But the asymptote involving x and y is going to change to this. Y is equal to y minus k, right? You have to change y to y minus k equal to plus or minus b over a of x minus h. That means you have two different equations in here. What? Y minus k equal to b over a of x minus h, and the second equation will be y minus k equal to negative b over a of x minus h. Okay? So far, so good. Similarly, we talk about the second type of hyperbola. Now we're going to have vertical hyperbola up and down. The second equation. So up and down, y is real, x is imaginary. So negative x squared over a squared plus y squared over b squared equal to 1. And we're going to sketch a similar graph. Let me erase this, have some space to write. X-axis, y-axis, same from origin. We move left and right A unit, right? We move up and down B unit, B here, negative B there. It doesn't matter which one's bigger. A could be bigger than B, or B could be bigger than A. Okay, that won't change anything. And then we're gonna sketch a rectangle. Okay. And now we still have the two diagonals, and of course, as usual, the two diagonals will serve as the two asymptotes. But now y is real, so the graph will not be left and right anymore. This time the graph will be up and down. So your hyperbola is going to be this way. Okay, and pretty much we have the same information, but the vertex now is not an A anymore. The vertex will be at 0, B, and this is called B1 up here. Okay? B2 is at 0, negative B down here. Okay, and F1 and F2 will be up and down. So F1 will be up here, F2 will be down here, and this is going to be C, negative C. So F1 will be at 0, C, F2 will be at 0, negative C, and of course C squared is still A squared plus B squared. We have the same equation for the asymptotes, which is y equal to plus or minus B over AX. Okay? And if we change to the new center instead of at origin as a random point center at H, K, the new equation, the more general equation will be negative of x minus h squared over a squared plus y minus k squared over b squared equal to 1. Okay, and of course the asymptote is going to change as well. Alright, and change to what? I need to get some room to write. I'm writing too big. Okay, let me write it. Y equal to plus or minus b over ax. Now change to y minus k equal to plus or minus b over a x minus h. It's the same thing as before. Nothing changed. Okay, that's everything about equations of hyperbola. I think it's time to give you guys some example and show you how to sketch a graph and plot the point. And we're gonna go. Start with the first example. X squared over 4 minus y squared over 9 equal to 1. So in our example right here, A is equal to 2. Keep in mind that I always use A goes with X, okay? and b is equal to 3, goes to y. X is plus, y is minus, x positive, y is negative. So x is real, y is imaginary. So the hyperbola will be left, right. So let's get the graph. X-axis right here, y-axis right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, negative. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. All right, A is 2, so go right 2, go left 2. B is 3, so go up 3, go down 3. Okay, and you guys see that we are having a rectangle. All right, now we draw the two diagonals of the rectangle, which are the two asymptotes for the hyperbola. Okay, and it's x positive, so it's going to be horizontal, right? So left or right. Our hyperbola is going to look like this. So V1 is at negative 2, 0 right here, negative 2. This is 2, V1 right here, V2 right here. V2 is at 2, 0. Okay, the two foci is going to stay on the x-axis, and we can calculate c squared, add them up, 4 plus 9 equal to 13. So c is equal to square root of 13. Okay. Square root of 13 is bigger than 3 but less than 4. So it's going to be 3 right here, 4 right here. So somewhere in here. This is F2. 1, 2, 3 right here. F1. So F1 is at negative square root of 13, 0. F2 is at positive square root of 13, 0. Okay. Calculate C right here. The equation for the two asymptotes are y is equal to plus or minus b over a, okay? Rise over run. This is 3, negative 3, so rise 3, run 2, plus or minus 3 over 2x. So let me write this way, plus, and then y equal to negative 3 over 2x. You have two equations for the hyperbola. This one right here. Positive slope, y equal to 3 over 2x. Negative slope, y equal to negative 3 over 2x. Okay, we have two foci. Okay, now we know everything about this hyperbola. We have the asymptote, we have the vertices, we have the two foci. Actually, there's another thing called the eccentricity. We'll talk about the rectus line, just like the parabola, but our textbook didn't mention it, so I think that's good enough for you guys to know and do your homework, learn some about conic sections. All right, that's the first example. Hopefully this helps. Let's move on to the second example. This time I'm going to change the center to a random point, not at the origin. Example, negative of x minus 3 squared over 16 plus y plus 2 squared over 9 equal to 1. So in this example, the center is not at 0, 0 anymore. This time the center is at 3, negative 2. Okay? H is 3. K is negative 2 because y minus negative 2. Alright? And A here is 4 because 4 squared is 16. And B here is 3 because 3 squared is equal to 9. X term is negative, Y term is positive, so the graph will be up and down. Okay? The vertical direction. And of course in here I can calculate C right away. C squared is sum up, so C squared is equal to 16 plus 9. Example, so give you guys a nice number, 25. So C is equal to 5. Okay, let's sketch a graph. It's going to be a big one, so let me see. Center is at 3, -2. We draw this way. This is my y-axis. This is my x-axis. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Start with the center. The center is at 3, -2, right here. Center. Okay, this is 3. This is -2. Alright. So this is your vertical axis for the hyperbola. This will be your horizontal axis for the hyperbola. Okay? And we're going to start from the center. Center right here. 3, -2. A is 4, so we're going to go left and right 4 units. 1, 2, 3, 4. Oh boy, this one. 4 units. 1, 2, 3, 4 right here. Okay? And center right here, we're going to go up and down 3 units. So 1, 2, 3. 1, 2, 3. Down here. And of course, as usual, we're going to have a rectangle. Okay? Center at 3, -2, up and down 3 units, left and right 4 units. We have the center. We have a rectangle. Of course, we're going to draw the 2 diagonals. And as you already know, the 2 diagonal will be the 2 asymptotes. Okay? And you know the graph will be up and down, so our hyperbola will look this way. Okay. Alright. Now let's try to determine all the points. We start with the center. Center at 3, -2. The 2 vertices will be up and down. It's going to be V1 here, V2 here. Up and down, we are changing the y value. Alright? So how far do we go up and down for y? 3 units. A is 3. B is 4 and A is 3. Just rewrite it. And C is 5 right away. Know that, right? So what? The vertex will be 3 and -2 plus or minus up and down how far? Oh, I'm sorry. This is oh yeah, B is 3, A is 6, 4, B is 3. I wrote backward, right? Sorry. Right. A is 4, B is 3. Up and down 3 units. So we're going to add and subtract 3 from the y coordinates because this is the center and we go up. The center 3 units go down. From the center 3 units, add 3 and subtract 3 from -2. So we have 2 points, V1 and V2. V1 is up there, so add 3. We got 3, 1, -2 plus 3 is 1. And V2 minus 3, so what? 3, -5. 3 here, -2 minus 3 is -5. So this point right here adds 3 and 1. The second point, 3, and this is going to be -5. Okay, this is 3, -5. This point right here is at 3 and 1. Okay. Similarly, to find a 2 foci, we also start from the center, which is 3, -2, and then add up, subtract C, which is 5 in our case. So we have 2 foci as usual. F1 is at 3, 3, and F2 is at 3, -7. 0 right here, 1, 2. This is F1, 3, 3. This is 3 right here, 2 right there. This is F2 right here, 3, -7. This is -7. Okay. And then last thing that we have to figure out in here is the 2 asymptotes. I'm going to erase this, okay? I need some room to write. The equation for the 2 asymptote, you know that h is 3, right? And k is -2. H is 3, k is -2. Two asymptote will be y plus 2 equal to plus or minus b over a slope 3 over 4 of x minus 3. And in this case, you have to really split into two equations. So let's write the first one as this. The second one gonna be y plus 2 equal to -3 over 4 of x minus 3. Okay, and then simplify with a little algebra. Let's do the first one first right here. Y equal to 3 over 4x minus 9 over 4 minus 2. So y is equal to 3 over 4x. This is 8 over 4, 9 over 4, so this is minus 17 over 4. I distribute the 3 over 4 to the two terms and I subtract the 2 on both sides. Okay? The second equation right here, y is equal to -3 over 4x plus 9 over 4 minus 2. So y is equal to -3 over 4x plus 2 is 8 over 4 plus 9 over 4 is going to be 1 over 4. Okay. So we have two equations for the two asymptotes. This one right here is y equal to 3 over 4x minus 17 over 4. The second line right here is y equal to -3 over 4x and then plus a quarter. That's pretty much it for this section. You can, I suppose, give you another. I plan to give you another example, but I think you guys can figure it out by yourselves. So I'll stop right here to make you think a little bit more. What if I have a plus sign right here and then a minus sign right here? So what if x is real and then y is negative? You guys can figure it out. What x will be the real axis, y will be the imaginary axis. This time everything pretty much the same, but the hyperbola will not be up and down anymore. It will be left and right because x is now positive. Okay, so the two foci f1 and f2 c still 5 in this example. Okay, but the two foci will not be on the vertical line anymore. It will be on the horizontal line. And then to find the vertex or the two foci, you don't add or subtract a value from the y coordinate anymore. This time you have to add and subtract a number from the x coordinate. I'll let you do it by yourself to help you to understand it a little bit more instead of writing everything out for you. Okay, but very similar. So please try to practice another example by yourself with changing the sign. X positive and y is negative. You see some difference. The asymptotes are the same. A, B, C values are the same because the frame is actually the same. Just the hyperbola will be left and right. So the two vertices will be left and right. And two foci will be left and right. So you have to calculate the new two vertices and foci. It's a little bit different. Add and subtract from the x coordinate. Okay? And that will be all for chapter 8. Thank you very much for watching. If you have any question, please ask.